Hi, this is an introduction to djuli, which is an online data sharing and data storage and data analysis system. It has some similarities with electronic lab notebooks, but it's really designed to sort of unlock the experimental network value. So the first thing I'm going to do is just define what we mean by experimental network value. So if we think about a single scientist in a laboratory, then the single scientist will have a sort of ENV, or an experimental network value, of essentially 0. And this comes about because, unfortunately they're on their own, they don't have any, colleagues, and therefore their network value is 0. Now if you bring another colleague into the system, and those two colleagues are well coordinated, and that is really important. If they're not well coordinated, then you really have an ENV of 0 with the second colleague. But if they're well coordinated, and obviously because I'm introducing djuli, which is this cloud system for really experimentalists to collect, analyze, share their data, then I'm going to argue if they're well coordinated through a system like djuli, then their ENV value is 1. Now if you bring a third colleague into this, now you have and they are again well coordinated, then you have an ENV value in this case, or an experimental network value of 3. And finally, with a fourth colleague, if they're well coordinated with the previous 3, and again I'll argue that having cloud systems for experimentalists to be able to store, maintain the structure of their data and to share their data, then you can have an ENV value in that situation of 6. Now, it's not unusual in many of our types of programs to actually have, 2 more colleagues who are also interested in seeing and collaborating with the data, or collaborating on the data. And in that situation, you have to have a very well, a central system that can coordinate all these efforts in terms of, where the data is, the structure of the data's searchable, people are following consistency. Then at that point, then you can have a ENV of 15. So there's essentially 6 colleagues in the in the experimental network, and the experimental network value is 15 at this point. Now this ENV value scales with number of people actually in the network. So if you have so let's say number of people in the network along the along the x-axis here, and the inherent experimental network value, then you can argue that a team of 25 people that are well coordinated would have an ENV, or experimental network value, of about 300. Now if the team only increased to 35, then in fact the experimental network value actually goes to 600. So as long as people are well coordinated, the data is centrally located, the data is searchable, there's structure in the data, everyone's following the same sort of data collection and data reporting protocols, then you can have almost like an exponential function with the number of people involved in the experimental process can give you an exponential return. As you increase the numbers of experimentalists, then the ENV value of the network actually goes up. Now the situation is that networks of experimentalists, maybe within a lab, maybe between labs, maybe between collaborators, the efficiency is not as high as you would like it, and any kind of inefficiency is sort of shown by this arrow diagonal, so saying that you've got the head count, but in fact your efficiency is less than 100%, so your ENV value is less than you would ideally want. And in some ways, the more people that you have in your experimental network, a slight deviation from best efficiency, and in fact you can really depreciate the overall value of your experimental network. So I'd ask a few questions. If you can answer can you answer these questions positively, which is, where is my data? If you can't answer these kind of questions positively, then you do have a problem, and you do have to consider a system like djuli. So questions are, where is my data? Is my data organized? Can you answer that positively? Are the experimentalists using the same structure in experimental reporting? Can everyone in my internal experiment network access the data? So can all my internal colleagues see the data? And then the second question, can everyone in my external collaborations access the data? And this is really important because you obviously want to organize your internal effort, but you also want to be able to efficiently share data using permissions, of course, with external collaborators. And can you answer these questions, all of these questions positively, that actually that is the case, that you know where your data is organized, everyone's using the same structure, I am organized internally, and by the way, everyone externally who needs to see the data can also see the data. If you can answer those questions positively, great. If not, then you're probably not really getting the ENV value from your experimentalists that you really should be getting. So for us, djuli really is about sort of unlocking the experimental network effect. That it's good to have smart people in laboratories doing experiments, but you really need to unlock that network of experimentalists. And if you unlock it, then it's non-linear, your return on people in the lab. So if you are not well coordinated, then essentially every experimentalist is just your power of your network is just increasing linearly. But if you actually have a well-coordinated team, and then in fact every member of the team gives you a sort of exponential return on that extra team member. So are you really unlocking the team? The djuli for us, djuli is this cloud system, actually gives us structured data capture, and it organizes the data into really a hierarchy of clusters which contain projects, and projects contain reports, and reports are really like an electronic, or rather like the pages in an electronic lab notebook. And if the term electronic lab notebook is not so clear, then that should become clear as we go through this. So we will talk about, we have a structure of clusters which contain projects, and projects really contain reports, and reports are really like the pages in an electronic lab notebook. And what these reports do is they guide really consistency in experimental reporting and data capture. And these reports allow you to have CSV data, electrochemical type data, images, video, notes, and then things like who the operator was, the time of the experiments, the kind of metadata. So it's good to have those kind of values around it. What's really important about this djuli system is it allows the experimental owner, be it the principal investigator, the chief scientific officer, the lab manager, the scientific lead, to structure how they would really like the experiments compartmentalized, because the experimental lead can decide on the cluster, they can decide on the projects, and then they can invite people into those clusters and into those projects, and then people can contribute into them. So at some, you can strategically decide on the structure and then tactically have people contributing material into that structure. And based on permissions, people within, internal collaborators within the same lab can see each other's data. But you can also then share the data with remote labs. You're not in any way, because this is cloud based on geographical constraints. The reports, which is the sort of, you have clusters, projects, and reports. The reports have an automatic way of generating reports as in terms of a PDF, etc. This is really important, that the reports are searchable. So many file document systems are fine, but it is sometimes hard to retrieve experiments that you might have done 2 years ago. So the ELN system is searchable, and also, though I'm not going to dwell on it in this particular video, the ELN also has data analysis tools so that you can actually turn raw data into data through filters and smoothing, etc. But I'm not going to dwell on that today. What's really important as well is that the data belongs to the cluster owner, and the permissions are controlled by them. There's, a certain amount of, custodianship, where, who owns the data, where is the data. So custodianship is really important, especially in startups. So the problem is that, I've stated it already, but businesses, startup, institutions, academia, it's not really getting the full value of their experimental network. If you can say that everyone in your lab is on the same system, everyone can see everyone else's essentially lab book, and they can all look at it and share it and collaborate around it, that's great. But that really is very rarely the case. So, if you look at a single lab, you could have, 3 scientists in that lab, and each one of those scientists, unless there is a structure in place like djuli, they can essentially be on the same project, but actually find it very hard to share each other's data and look at each other's data without actually going to ask one another. And then there's a situation that you actually could have just as many stakeholders, like the CEO, the CSO, the principal investigator. They could also be interested in seeing this data, and in fact their only way of really seeing the data is to ask for meetings of people to present the data, and that is quite a common scenario. So we are here to talk at a very high level really about, you've got an experimental network or experimentalist network of people doing experiments, and you can really get the true value by having them properly coordinated in storing their data, sharing their data, analyzing their data. But in order to do that, you have to have a sort of structure in place. Now, there's really a sort of worst case scenario, which is probably what's commonly happening, is you will have 2 scientists who may actually be using different places to store their data. It could be OneDrive, it could be Google Drive, it could be Dropbox. Hopefully not happening, it could be their local computers. Obviously the local computers is the worst case scenario, because this really comes to the backup of data as well. Where is my data being backed up? If that hard drive goes down, there's no real guarantee that the data is backed up. But hopefully they're using OneDrive, Google Drive, or Dropbox. Now, one of the concerns about this is cloud file storage systems are really intended for storing documents, Word documents, Excel documents, PowerPoint. They're not structured to contain experimental data, so they're not really fit for purpose. It is hard to maintain consistency of data collection, data presentation across these different systems. And sharing data with external collaborators. So, for example, if one company's on G Drive and another company's on Dropbox, and the one company invites another company to share its data, you can have a scenario where, in fact, people are using their personal Dropboxes or their personal G Drives to look at another company's data, at which point the data is getting into those personal accounts, and you've really lost custodianship on the data. And then it really leaves you with a question, then really who owns the data? So this is probably quite a common scenario, what's actually happening with data. Now, if we dig in a little bit deeper on that, even if everyone in the company is using G Drive, and there is meant to be a folder system in place, just the human beings, we're not robots, so we will end up putting the data into different folders, and maybe the files are not quite the same between different operators, which is fine for the individual scientist. But if I'm an external collaborator or an internal collaborator, so in the case of an internal collaborator, I might actually find it very hard to search and find the data, maybe even impossible, without going to ask that scientist. The structure within these folders is not necessarily regulated or quality controlled. That's a big issue. Very hard to scale this. When each scientist is essentially doing their own thing, the more scientists you've got, then the higher, I don't want to say chaos, but higher the disorganization actually becomes. And this is very hard to collaborate with people outside of the organizations. And what's happening then in that situation is people are really sending, experiments, via Slack or some sort of email. And at which point then those experiments are kind of out of context of the body of experiments. So you're sort of losing the value a lot. So it doesn't work well internally, and it's probably even worse when you're trying to actually collaborate with others. Now, obviously, the solution that we're suggesting is djuli, and it's very scalable because, in fact, it's just a simple sign up online, and at which point then people have accounts, and you can start inviting those people then into your clusters and into your projects. Just through an email, they can log in using their email and their password. So we have discussed this, that there's a, as a owner of experiments, you'd be very interested in the structure. So there's clusters. Clusters contain projects. So in a bit, I will show you that we have clusters, and then under a cluster, I have a cluster called fish tag. Under there, I might have two projects called cortisol and glucose. And then under that, then we'll have reports. So I'll have fish tag as a cluster. One of the projects would be called, for example, glucose. And under there, then we could have reports, which are really put there by the scientists. And in the reports, I can have electrochemical data, images, video, notes in the form of text, and then metadata about what who did the experiment, when was the experiment done, and what was the reason for the experiment, what were the conclusions. Now, this is important because as an experimental manager, you basically define the first, you define the cluster and the project, and then you can invite people, the experimentalists, to actually do the or provide reports or the pages of the electronic lab notebook underneath the structure that you've actually put in place. So you essentially define the structure, and then essentially the doing happens. Let's just go back one. The doing happens underneath that structure that you've now put in place. So now you kind of, first of all, you know where your data is, because it's your account. You're the one who created the clusters and the projects, so you know where the data is. And then you've invited these experimentalists, and then they're putting their experiments into your projects. So what does this actually look like? So these are some screenshots from the djuli database. And so we have essentially clusters that I own and clusters that have been shared with me. So we'll talk about sharing later on, but the sharing is really important because the whole point is that the ENV, the experimental network value, it's really important to unlock that and maximize that. And so sharing is the heart of what we're talking about today. So we have my clusters, and then we have clusters shared with me. Now, it's easy enough to create a cluster. You just have a sort of cluster creation button here. And if you want to refresh and see what clusters you either own or you have been shared with you rather, you can do a refresh here. So that's simple enough. Now, if I dive into one of my clusters is called fish tag, then I will see underneath my cluster that I have my cluster is called fish tag, and I have a couple of projects called cortisol and glucose. So if I dive into my project called glucose, then I have a whole list, almost like a flat list of experiments. Now, these experiments are in chronological order. So I already now, look, I have my structure, at least I have a structure that the human mind can start to think about. I can see things in a sort of chronological order. I can see, but really importantly as well, that this flat list, and this flat list here, by the way, goes on for several pages, is searchable. So you can, search on keywords and start finding, let's say lost data from 2 years ago. But it's important now because as the experimental owner, you want to know where is your data, and you want to then be able to find material within that data. So it's important that we have a searchable option. The unit within all of this is the report. So I say that the report is really a page of an electronic lab notebook. So if we dive into a report, what we'll see is important metadata about time of the experiment, the operator, the hypothesis, the experimental protocol, the equipment used. These are useful data points to give you context. Then you have raw data, which looks pretty ugly. And then you have extracted information from that raw data. But you know where this report is. You designed the cluster, you defined the project, you invited the operator, In this case, I know that this operator is invited, and they've done the experiment, and then they've put the experiment into the project, and you can then search on it using keywords. And the report, though we're very biased at this moment towards bias-centered electrochemical data, you can also put images up there. Now, I'm not going to do is dive into the toolbar. That's really for a more detailed discussion about what to do with data within, let's say, djuli. But today we're really talking about unlocking the ENV, the experimental network value. But there is a whole toolbar there as well. Lastly, on reports, and I've said it already, but it's searchable. And this really is important for collaborators, supervisors, people who really need to get in and find experimental data. So you could be the CEO of your business, you could be the principal investigator, but it's searchable. I know I've said it, but we need to emphasize that as well. So we really want to talk about today about djuli really as a tool for unlocking the experimental network value. So let's talk about sharing and collaboration. So we showed this earlier on, and we said that you have my clusters and you have clusters shared with me. And it's simple enough to just right click on a cluster and invite people. So that's how you can invite people to clusters. And those invitations can be internal people, or it could be actually external people as well. So it's quite simple to share. Let's talk about case studies. Why should you do any of this? So let's talk about an internal collaboration. So at Zimmer & Peacock, we have several locations in at least 2 countries. And for example, we have on the left-hand side our A1 building in Norway. It's 4,000 square meters. And we have a much smaller 400 square meter in Coventry. Now, we might have a subgroup of scientists all coordinated on djuli, working on a project. And if they're well coordinated through djuli, i.e. we know where their data is, outside collaborators can look at it, internal collaborators can look at it, then we can give that network of experimentalists an ENV value of 3, so an experimental network value of 3. Similarly, we can have another team in Coventry also working on the project, and this does happen quite a bit for us, and they have an inherent experimental network value of 3 as well. Now, in these days of when I'm making this video, in days of COVID-19, it's actually very useful to have these disparate groups, because when you have lockdowns and shutdowns in one country, it doesn't necessarily affect another country. So we need to coordinate both these teams, both from an efficiency perspective, but also from a sort of project security position. So we do have them well coordinated through djuli. But what this means is that if I take a small group of scientists in one country with an ENV value of 3, and I take another small group of scientists with an inherent experimental network value of 3, and I coordinate them through my djuli again, I actually have an ENV which is 15. So this point is that the sum of the 2 halves is greater than the sum of them individually. So it's not an ENV value of 6, it's actually an ENV value of 15. So that's more than twice the individual ENV values. Now this becomes very important, and I think with industry, external collaborations are very important, but also in academia it's also very important, because in academia you'll have external academic collaborators. You also have external industrial collaborators. So within external collaborators, we can have our researchers in Norway with their inherent ENV value of 3. We can have our internal team in Coventry with an ENV value of 3. As stated, we bring the 2 teams together through djuli. They have djuli internally, and then they are also coordinated through djuli. We now have an ENV value of 15. Now, and this happens quite a lot, the external collaborator also has an experimental team, and they're using djuli, and we combine them through djuli with our teams, we now have an ENV value of 36. So this is really important, because now, if you just summed up the individual ENV values, you might have 9, but by having all the teams properly, we know where their data is, we can search their data, they can see each other's data, then the ENV value really jumps up for that kind of coordination. And it's really only possible if you're using an inherent, a tool essentially like djuli, which is designed to exactly do this, which is allow experimentalists within the same lab, between labs, between different countries and time zones to collaborate correctly or properly. So just to drop on that time zone and continent, it's not unusual to actually have experimental collaborations with people in different continents these days. And once upon a time, there would have to be meetings in order to essentially update each other. But really, with a system like djuli, which kind of resides in the cloud, then it's not so important to have those formal updates, because you can really, as long as everyone is on djuli, you can see the real-time updates because it's all going to the cloud in real time. And so you can see it. So let me just kind of finish by saying djuli is very scalable. Literally, it is just a web page with a sign up, at which point then you can log in, start creating clusters and projects and inviting other people to, or you're using it yourself and inviting internal collaborators and external collaborators to also use the system as well. So if you've got any questions, please don't hesitate to contact us at Zimmer & Peacock. Okay, thanks very much.